What if I told you there's a simple object, a spinning wheel, that seems to just completely ignore the laws of gravity? We're about to see it in action, and honestly, it might just make you question everything you think you know about how weight works.
I mean, just listen to that. How can something so heavy all of a sudden seem like it has no weight at all? Let's try to figure this out together.
Okay, so first things first, let's get a real feel for what we're actually dealing with here. Because this isn't some trick prop from a movie. This thing is the real deal, and it is seriously heavy.
So, what are we looking at? Well, it's a 40-pound, that's 19 kilogram, flywheel. And it's on the end of a pretty long shaft. Just to put that into perspective, that is a lot of weight to be holding at a distance.
Think about that for a second. That really paints a picture, right? Imagine trying to manage that unwieldy weight, all of it concentrated at the very end of a stick. It's just awkward.
So let's just pause here and really imagine this. You're holding one end of that stick. Do you think you could keep those three bowling balls from just crashing straight down to the floor? And yeah, that's the answer, right? Of course not. It's pretty much impossible. Gravity does what gravity does, and that wheel just plummets straight down. So this is our baseline. This is how the world is supposed to work. But what if we change just one single thing? We're not going to make it lighter. We're not turning off gravity. All we're going to do is make it spin really, really fast.
And this is where the paradox really hits you. On the left, you've got the wheel behaving exactly as we expect. It just falls. But on the right, you give it a few thousand RPMs and it just floats. It's like it's completely defying that immense pull that was dragging it down just a moment ago. Seriously, if your brain is doing a little backflip right now, that is completely normal. You're not supposed to get it right away. That feeling of confusion, that just means your brain is wrestling with something that's genuinely counterintuitive. And that, right there, is where the real learning starts to happen.
So what is the science behind this magic trick? Well, the effect has a name. It's called gyroscopic precession. The easiest way to think about it is to picture a spinning top. You know how gravity is always trying to pull it down? But because the top is spinning, that downward force kind of gets redirected. Instead of just falling over, the force pushes it sideways. And that's what creates that familiar little wobble. The wheel is doing the exact same thing, just on a much, much bigger scale. It's not actually weightless. The force of gravity is just being channeled in a whole new direction. But hold on. The mystery doesn't stop there. Holding it horizontally is one thing. What happens when you actually try to lift this thing? This is where it gets even stranger. Okay, so first, let's set another baseline. Trying to lift the non-spinning 19-kilo wheel overhead with one hand is an absolute battle. It's awkward, it's a huge strain, and as you can see, it's just barely possible. So remember that struggle. Now just look at the difference. It's the exact same person, the exact same weight, but when it's spinning, the lift is smooth, it's controlled, and it looks almost effortless. The struggle is, well, it's just gone. And this right here is the heart of it. The person lifting it says it feels incredibly light. It's not just that it's easier to lift. It feels like the wheel is actively helping him, like it wants to go up all by itself. So, this brings us to a really fantastic question. Is this just a trick? A trick of our muscles and our brain, a weird sensation caused by all those gyroscopic forces? Or does the wheel actually physically become lighter? Feelings can be misleading, and science demands proof. So we need to go from it feels lighter to something we can actually measure. We need an experiment. Okay, so let's get some hard data. Scanning on a scale, our host here weighs 72 kilograms. When he picks up the static, non-spinning wheel, the total weight jumps up to 91 kilograms. That's a 19-kilo increase. Exactly what we'd expect, right? No mystery there at all. And that brings us to the final puzzle. We know the baseline weight is 91 kilograms. We know it feels almost weightless when you lift it. So now it's time to put that feeling to the ultimate test. So here is the question for you. When he lifts that spinning wheel over his head, the one that feels like it wants to fly up all by itself, what will that number on the scale actually say? Will the total weight be more? Will it be less? Or will it be exactly the same 91 kilograms we measured before? What do you think reality is going to show us?